Hello, I am Taivo Liik, and I'm going to talk about the cloud. Stairway to the cloud, or can we take the highway? I know it sounds like 80s rock and roll. Basically, this is my almost the same haircut. I've been working in Playtech over 6 years. I worked in several software development units, actually even positions. Now I'm just leading the programs, and our biggest change this year is that we are moving away from virtual machine-based approach to the cloud-based approach. And this has actually been very complex and very difficult year for us, because a lot of changes has been introduced. And basically today, we have 3,000 physical servers all over the world. We have 25,000 virtual machines. And on top of them, basically we have over 100 deployable application servers. Those servers actually are being developed all across the globe. We have units basically everywhere. We have new versions, new features coming out every week. We have obstacles, we have topics. How do we scale those applications? How can we cut down the cost of the deployment? And basically, last year, my colleague spoke about cutting down the monolith approach to microservices. So we started to having more and more microservices. We took everything, make APIs separated into different virtual machines, or consolidated into same virtual machine, but service was different. So since we are doing them constantly, the need just increased, that we need some faster deployment. We need to have more flexibility to upload them, to scale them. So it also all needs to be highly available. We have the policy of no downtime. Basically, 99.9% is our agreements with our clients. And we have more configuration. Each server needs configuration. We have logs everywhere. In each virtual machine, each server produces their own logs. And of course, the middleware. So it's basically similar as a house. You have a house. You have a map. You know where is this building located. You know the size, you know how many windows, doors. If you put some guy here on the door, the guy just can sign you in and sign you out. You have security. It's well known, very safe, very common. This is today our virtual machine. It's same approach. So we started thinking as platform as a service for our applications. Easy development, easy deployment, needed to run and scale applications, and it needed to be highly available. Also, we thought of everything just put down into one list, and we thought, okay, we have clouds. Cloud is actually a quite old technology. It started last decade or even earlier, but it has been grown and grown. So if you talk about cloud, the product itself, we have a choice, or actually we have the question or the decision to make. Is it open source or commercial? Is it public or private? And there are actually other options also, like there was this SETI project where you can install a bit of application in your laptop, and you were joined in a big community where calculations were made. Anyways, we have those 4 questions. First of all, open source to commercial. We really thought that we will take the commercial approach. We had so many options. We have the money, we can buy. We have option to get specialists from the commercial company. We have easy setup. People will come, make the setup. We have trainings. We can basically take everything from this commercial company who is providing this cloud. But what happens if you need to have new features, some specific items? You go to the company, say, I give you money, please make me this feature. But this company says that, sorry guys, but this company pays us more, and their features are top priority. You may have to wait for the features in line. And what happens when the commercial cloud provider goes to bankruptcy? We are just sitting there with our legacy product, and we don't have anything. But with open source, we have community. We can fork the main branch, make our own cloud, or we can just push back the changes to the community. Just and the support is actually very, very big. You have the forums, you have people who are actually keen on this, and you give something to the community, you will receive something back. And then the second question, is this the public or the private? This is also very difficult. We all know this public clouds. We know Amazon. It's very simple. You just open the web page, give them money, just 2 clicks, and you have this cloud. You have the storage. You have resources available. But if you have very delicate data there, you want to make audits. You want to know for sure that this public cloud provider keeps your application safe. You are protected from attacks. You are constantly being, you have to make sure that you are not constantly being watching, have been watched from the public cloud provider. Or then private. You have to have your own middleware. Actually, even hardware, not middleware. You have to have your servers. You can deploy the cloud there. Okay, it will cost you money. It will cost you knowledge. You have to know how to set up servers and maintain the servers. So we put all those topics on the table, and we chose actually open sourced and private. So we can take the code from GitHub or wherever, which is nice, and we can deploy it on top of our own hardware. We have 3,000 physical servers, so we can utilize them. And we chose actually Cloud Foundry as our product. And again, what happened with house? We don't have any more house. We have just one big cloud. It's like air balloon. But in our example, we have one line connected to the ground. Basically, the balloon is with one line on the ground, and you know where is this endpoint. You know that from there, if you go up from the line, you get to the balloon. And you're gonna have several things in the basket here, but you really don't know where the balloon is because, you know, it's just flying there. So, from virtual machine to the cloud, we don't have any more permanent storage. Cloud itself, the concept, is that your application doesn't have permanent storage. Your with Cloud Foundry, you have limitation that you will only have one port open to the outside world. So but this is the line. You can actually connect to the application only from one port. But the application itself can establish connections over multiple ports, as much as you need. And with the cloud, we have now flexible scaling. With one button click, we have new application server running. With same button click, you can just destroy it. You don't have any more. That's why it's very, very difficult to understand where your application really is. It's in the cloud. And you don't know how long this lives. It might last 1 second or even years. And we had a very difficult question: where to store the application startup configuration. Of course, you can package it inside of your application package, deploy it, and it's there. But in our case, we have 50 or even more sites all over the world. And for each site, we have different configurations for application. So you have to make like 50 different packages for all those sites. And you have like 100 of them. It basically was not an option for us to package the configuration inside the application package. And since we don't have any more the storage, we stored the logs on the virtual machine, and we had a service that collected the logs from there. But today, in the cloud, we don't have storage. We can't write it anymore to a virtual machine disk. And we had a solution where monitoring itself went to the cloud and asked, hey man, are you alive? Are you alive? What's going on? But now, since this port is closed, we don't have this option. And we needed also a solution for this. And one of the complex topics is that each application required its own middleware, its own versions, whatever is not necessary. Was it web service, or was it just server which is meant for transactions? And all deployment changes also. In the past, it was very simple. Just push the RPM to the virtual machine. You have middleware there, and install the RPM, and you have it. With cloud, we don't have this option. We don't have virtual machine. You have to change all those points. And certainly, we don't know where are our application nodes, and we need to know. So, the logs. We don't have it anymore in permanent storage. And we needed to have the solution for this. So we chose Kafka. It's clustered for availability. And application pushes its logs to Kafka. Kafka has got many nice features for this. We can even subscribe to some specific events which will happen. And Kafka just tells us that this event happened now. But we are just using Kafka today for like log collector. And this Kafka will run on virtual machine. But virtual machine disks are quite expensive. They basically are very, very vault-tolerant disks. So we wanted to get away from expensive disks and start using the Hadoop-based solution. We have logs replicated 3 times, and it's still cheaper than the store in virtual machine. So basically, Camus jobs are pulling the logs from Kafka and stored into the Hadoop file system. And now we are actually changing the Camus jobs to copying jobs, because Camus now was deprecated, or is being deprecated. It's a very nice library from Liik, actually. And since we are pushing the logs to Hadoop, we can very easily read those. And we have just Hue, and in Hue we have also Hive and Uzi for making either SQL queries with logs or just doing some analytics. And this is the Hadoop itself. Again, open sourced, easy to use, documentation available. And since we don't have the storage, we have a problem about the key stores and configuration. Firstly, we had the configuration in XML file in a virtual machine. Application came up, pulled the configuration from XML. That's all. You can package the configuration file inside the application package, but still we have so many applications, and it's very difficult to track them. And we can also store the logs in central location. Of course, database is an option, but database has got very many disadvantages. For example, you don't know who made the changes. You don't know which was the older version. It's just database, it's just rows and tables. So we moved our configuration to Git. I bet that you all know what Git is. And we can read the logs from Git. We can push new logs to the Git, central Git. But Git isn't actually very good for key stores and passwords. If you want to make the changes for some part of the system, you just go to the Git, change one number, change one parameter. But you want to keep your key stores and passwords in the safe location. With Git, application can read the log. With Git, everybody who has access to the specific branch can read it. So we are moving the key stores away from Git. We are moving them to the solution called the Vault. This is vaultproject.io in internet. The symbol. This. So basically, Git will have index of the key store location in Vault. Application takes the index, connects to the Git, authenticates himself, and gets the key store or the password. And it has very good monitoring, logging, audit systems built in. It's out of box. So if people need to change the configuration, they can do it in Git. If you need to add a new key store, just upload to the Vault. Full trace, everything is known. And you can just limit access per person. So I spoke about monitoring. If you just pulled the status from the application, if the port is closed, we can't pull. And we had alternative monitoring running with Graphite on top of Whisper database. Graphite actually is a library from, even tool from Vimeo. And this is one of our big sports events. Those are all Graphite metrics here. People just were tracking. If something goes bad, you can instantly see. And we needed to have solution highly available. The Whisper database is not. And we didn't want to change a lot in our current approach. So we chose influx database. It's from our side point of view, everything's the same, but influx is actually very easy to be clustered. And we got an additional tool like Grafana. With Graphite, you have to know the system, and you can just build the dashboard, just basically over console. This is actually, they have this interface where you can type the metric and make the graph. But with Grafana, it's very, very simple to do for everybody. You don't have to be very knowledgeable. You can just take the metrics, drag, drop together, and you have the dashboard. But we had this also the legacy system, which went to application and asked, how are you? Now the legacy system goes to the influx database and pulls the status from there. And we still have all those alerts available. We still have overview. And so far we have covered the log solution, Kafka and Hadoop. We have covered configuration, Git. We have covered monitoring, Graphite, Grafana, Influx. And we have covered key stores in the Vault. But we still had the service discovery. If you have the virtual machine, you know where it is. You know the IP address of the application. You know DNS record. You know where the application is located in your virtual machine, in your physical machine. With cloud, it's a bit different. We had all this information in database. We had record, server, IP, access point. We had everything there. And with cloud, what happens? Application can come up, write himself to a database that I'm here, but when application is pulled down, who removes the record? The application itself can't because it's already dead. And the second topic is the middleware. How we are solving the middleware question. Because in virtual machine, you have middleware in place. You can pre-install it. But the topic is that upgrades will take time. If you have applications which needs to be up all the time, you can't make downtimes. Downtimes are costly. For you, for the client, everybody are losing. So we just took the record away from the F5 pool. We took down the application node, and we pre-installed middleware in the virtual machine. Reinstalled the application and put back to the F5 pool. And it's highly available at least 2 times. We have to do it for per application, sometimes even more. And with the cloud, we can just write down in the manifest JML file, which is our middleware need. Cloud Foundry has got the blob store where the middleware is located. You can compile your own package using Cloud Foundry API. You can push it to the blob store, and now you will have your own middleware in Cloud Foundry blob store. And this manifest JML is just define it there, and you really don't have to worry anymore. The rest of the job will be done by the Cloud Foundry. Just tell Cloud Foundry, push my application with this manifest JML file, and the rest is done by Cloud Foundry. Cloud Foundry has got very specific structure, which I'm coming back to. So we have open question about still the service discovery. We don't have in database. We don't know where the servers are. But we know that Cloud Foundry itself knows. It has the API for this. We can ask always from Cloud Foundry, is the service running or not? And who needs this information was the load balancer. The load balancer needed to know where are the applications so we can do the job. Now the load balancer started to talk with Cloud Foundry over the Cloud Foundry API. And we don't have any more those past issues because now we just define that application is in the cloud and cloud infrastructure makes the rest. Yes. Yeah, because actually Cloud Foundry has got the API for this, and I think our network guys just made some hacks there today, and this is it about the load balancer. I'm sorry, I'm actually quite brief on these topics because the time is very small. I could speak like days, and we have the security part to cover. So today in virtual machines, we could make different network segments for different applications. And we know that application in this network segment can be trusted by another application in that same segment. And it is you have to do a lot of configuration on network level, all those firewall ports, rules, and so on. But with Cloud Foundry, you have this one big cloud, and Cloud Foundry takes care of the security just by each application is in specific organization. Like Cloud Foundry itself calls it orgs. Inside each org, there is spaces. So you have org, you have spaces, and inside the spaces, you have your application containers, and the application is running in the container. And you can have many orgs, but inside the application container, applications can talk with each other without any problems. In this specific space, it's pretty much the same. But application can't connect directly to another application in another org. You can have multiple orgs. And it means that in one Cloud Foundry installation, you can define different environments, like production, staging, testing, integration, you name it, you will have it all there. The flexibility which it gives is that in the past, when you made separate environments for separate use cases or business flows, now you have the same environment, you have the separate orgs. Developer has got his own org, his own org with own resources. You can define in Cloud Foundry that how many virtual machines how many CPUs it can use, how many RAM and how much you have space for the application. There is one very slight limitation in case if you have an application which is bigger than 4 gigabytes. I can't imagine how you do it. But if you have application greater than 4 gigabytes, then today Cloud Foundry doesn't support it. They are promising to support it in version 2 or something like this. You can store the media outside the cloud, just in some cheap location. You can just pull it from there. But application with middleware can't be bigger than 4 gigabytes. This is limitation in some cases, maybe somebody who has media files. We are using them just servers for transactions, which you're basically handling layers, wallet, and so on. So you need to have just transactions very available. Basically, it's perfect for servers, and not so perfect for providing media content. So the question is, did we take the highway or the stairway? we needed to do lots of changes. I'm not going through them all because we just covered them. And if you have a single application, single service, it is certainly in a highway. Just use the Amazon cloud, push it there, and you have anything in place. For us, we took the private cloud approach. We had to rethink our all procedures, rethink our application logics, where to store anything. We did a lot of work over this year to achieve this. Just like a month ago, we deployed our first Cloud Foundry application to production with Cloud Foundry, actually. And for us, it was a Stairway. But there's a benefit. Sometimes we have to take the stairs to reach the highway. You know, highways are high, and you are down. And the rest of the new applications, if you do it, we have the guidelines for us, it will be the highway. Sometimes you have to give a little to win big. So any questions?
Yes.
So, yeah.
Yes.
Yes.
So basically, Java applications
We did actually, the more Java applications. Yes. Actually, Cloud Foundry has got also services like predefined. You can use Cloud Foundry provided MySQL, MySQL, and but we are just using today our database is Oracle, and it's very hard. Today, since we had the virtual machines available, we installed it on top of virtual machines, but we are moving forward to install it on bare metal. It is supported. It's not a question if you can do it. It's when. Yeah. You mean to the cloud or outside the cloud? From one application to another application inside the cloud. Yeah. Inside the cloud, you don't even actually have to care how many ports are available, but you know that you can get to the cloud only over one port. Yeah. Well, to be honest, I'm not very. I don't know how much the Cloud Foundry provides the limitation of open connections. For me, for us, it's enough. Here was also one question. I think our time is almost out, and yes.
What are the performance implications of cost?
The cost is at the moment a bit higher than virtual machine-based solution. But the cost will go down if we were moving more applications to cloud. And what was the other one? Performance.
Do you have what service running?
We did a performance test with the server in VM and in Cloud Foundry. The difference was like maybe 1% Cloud Foundry loses, but it gives us so much back. So yeah, this 1% is of maximum 1%. I know my time is out, but nobody's coming in, so any more? You can always find me. I'm just walking around here. And so, thank you.